Hi everyone. I hope you can see my screen right. Hello.
Hello, I can hear you.
All right. Yeah. Okay. Welcome once again to another episode of our virtual class on math. And today we're still going to be delving more into geometrics. I think in the part of triangles, right? Okay. So I think
Yes.
I'll be doing more justice to that. And then for the student joining in and those of you that will be connecting live, do well to send in your questions, and then if you have any uh, comments or suggestion, also let us know, and then of course you give. Yeah. So I believe you can see my screen, right? And-
Yes, I can.
okay. Just like last week we introduced our teacher already. She's um, Miss Anoluwapo, and then she's a mathematician, an educator, and a pioneer of N Flyer Academy. And then operative focus, operative is to ensure that young people become successful in all they do. And then she's also responsible to help um, young people groom their innate skills, and then ensure that all difficult concepts are broken down to understandable pieces. So I believe we now have a clue of who our speaker is going to be, and then this should give you a forum for you to open up your mind and feel free to ask questions, and then let's keep the class interactive, right? So we get right to this the like class right away. So over to you, ma'am. Hello, ma'am, are you with us? Hello, ma'am. Oh, I see. I guess she. Okay, so while we await as a teacher to reconnect, I guess she had some network issues, so she'll be joining back shortly. So, to the students joining in, can you unmute and tell us a brief about what you learned last week? We're going to start with that. Hello, hello.
Good afternoon.
Good afternoon. How are you doing?
My thank you.
All right. So, can you tell us about your the class, what you learned last week?
Yes, ma.
All
We
right.
learned
So,
geometry, construction of angles. Sorry,
okay,
angles. No,
okay. So, how was the class?
it was interesting.
Okay. So, I guess you were given an assignment or a classwork. Was it done?
No, it was an exercise, classwork.
Oh, all right. Okay. So, all right, ma. Welcome back. Hi.
Hi.
Yeah.
Sorry,
Welcome.
my network is just not treating. I don't know why.
I get the weather because we also have the same weather issue over here. So it's kind of, I just had to
It
like,
has to obey. It has to obey. That's to hold this class.
It's gonna work.
Yeah.
So over to you, ma'am. So we're just doing a recap of what's the
All right, good
last week.
afternoon. Um, well, I'm
Good
coming.
afternoon.
Yeah. Sorry, please, am I permitted to share my screen already?
Sure, sure, you can. So I'll just stop sharing so you can share.
Like the permission. Sorry, I'm at
Go
home.
ahead.
I'm trying to.
All right.
You see me now?
Sure, we can.
All right. Good afternoon,
Pretty
everyone.
as always.
All right. So, as earlier said, my name is Anulu Akoli. I'm a mathematics teacher, a graduate of mathematics education from the University of Ibadan, and I'm a lover of children, of course, like you know. I'm also the founder of FBA Academy, so it's an opportunity, it's a great privilege to be a part of this house. Thank you for the opportunity for me to showcase my talent and also to contribute my quota into helping children become who they want to be through the knowledge of mathematics. I believe that mathematics is applicable in almost every areas of life. Even if you say you are not going to engineering, you will need calculation at some point or the other. At least you shall like money and you will make money, of course. So yeah, last week we were able to talk about geometry, right? And then we were made to see the difference between a segment, a line, and a ray. In actual sense, what we have been calling a line has actually been a segment. And you know, I know that some people will be like, what's this teacher saying? And some of you would have gone to verify. How many of you went to verify? Anybody here that verified?
Yes, ma'am.
Yeah, that's good. You know, I'm a Christian. I don't like bringing in this, but I want to bring this in. You know, the Bible was talking about Paul and his testimony of the Berean Christian. He said these Christians, whenever they are taught by the apostles, they will not say, oh, a whole apostle taught me, he cannot make mistake. They will go home and check their Bible if it. And that is the kind of habit I want us to cultivate. When you are taught anything, check facts. Anybody can make mistake. You know, last time I said nobody is an island. So I believe that you're prepared for today's class because it's going to be interesting as usual. And I pray God will help
Yes,
us.
ma'am.
So, who can give me the definition of geometry as said last week?
Okay, ma'am.
Anyone? Geometry.
Ma'am.
All right. Talking. If you are talking, let me know your name, please. Just say your name, then give me the
My
definition.
name is Miracle.
Oh, very
My
cool. Yeah. All right. What's geometry?
geometry is the study of shapes, size,
Yeah.
position, angles, and properties of space.
Yeah, that's so beautiful. Give it to yourself. Let me snap for you. So I snap and I still snap, I snap, I snap. That's so beautiful. That's amazing. That's to say that you actually put all what you were taught in writing. And that is how to retain knowledge. So let me just come from my summarized notes. I did not create a slide. I created a note and did it on my phone. All right. Geometry is a branch of mathematics that deals with shapes, sizes, and properties of space, like you said. Now, today we are going to triangles. You know, last week we were able to look at rays, line, segment. We were able to look at how angles are formed, which is the combination of two or more rays. We were able to look at perpendicular lines, alternate angles, corresponding angles, and so on and so forth. So we were able to establish that the sum of angle in a triangle is what? 180 degree. And also another buster that I gave you last week, which would have been like, wow, what is this teacher saying? Was that I told you that a line is an angle. It's an angle at 180 degree, right? Did we
Yes.
say such a thing? Yeah. So let's just delve right into it. Now, one of the fundamental shapes in geometry is the triangle. And every time in our daily life, we encounter triangles. So for example, there are some cookies that are shaped triangles. For example, most of us have mathematical sets, and we have this our set squares, and they are all in form of triangle. You go, when you are going up north and you are on the road, you just see, 20 kilometers ahead, and it's a form of what? A triangle, meaning that a triangle is a very crucial aspect of our life. And when we study triangle, we can actually apply it in various aspects of our life. So first off, let me define a triangle. Definition of a triangle. All right, a triangle is a three-sided polygon with three edges and three vertices. We know what a vertex is. Okay, let me just share my screen. I'm not yet permitted to share my screen though. All right, so let's continue. So it is the simplest form of polygon, and it forms the basis of geometric concepts. With triangle, you can do a lot. In fact, if you know triangle, you know rectangle, you know every other thing. How many of you agree with me that a rectangle or a square is a combination of two rectangles? Is a combination of two triangles, sorry. So by the time you draw one triangle, a right angle triangle, you put the other one on it, you are getting a square or a rectangle, depending on the hypotenuse. Depending on the hypotenuse. Don't forget, we were taught line of symmetry.
Please go ahead to share your screen.
Yeah. All right. Okay. So I was just having a little gist right here. I don't know. Please don't stress me. This thing should not stress me. Okay. So I want to share my screen. Can we see my screen?
Yeah.
No.
We can. I think
Loading.
Yeah.
You see my screen? Can you see the whiteboard?
Yep, we can.
All right. So let's delve right into it. I said that if you know this shape right here, sorry, I'm using my hand. You have known every other shape, because every other polygon is a combination of this sweet shape we have here. By the time you divide this into two, you see that you have one triangle here, right?
Yep.
Yes.
Another triangle here. Okay, give me another shape. Even if it is a parallelogram, you are still having the same thing. By the time you divide this, you are having, sorry, no, I'm not using the right stuff here. So we can also have, let's say we have a trapezium, for example. A trapezium somehow looks like this, right? And then you have something here like this. This is already a triangle 1. So by the time you divide this, you have triangle 2. And by the time you have triangle 3. So you see that almost all polygons are combinations of triangles. And once you can get it right with your triangle, you can get it right with any other shape that is on that polygon. So invariably, what I'm trying to say is that if you can know the area of a triangle, you can derive the area of a square, the area of a rectangle, the area of a trapezium, like I usually do. I teach my students not to cram formula, but to derive it. And so, all right, let's delve right into it. All right, so there are different types of triangles, and triangle can be they can be classified based on their sides. I mean sides, not size. Sides, and we can classify them based on their angles. For example, we have equilateral triangle. So let's talk about sides now. So equilateral triangle is a triangle that has all sides equal. All sides. Hope you are familiar with this sign. When you put this sign here and you put safety here, you put safety here, it means that they are congruent. Oh, last week I was meant to mention congruence. Two shapes are said to be congruent if they have the same size and the same shape, if they are exactly the same. They are said to be, so two lines are congruent if they have the same magnitude, right? So for the purpose of this class, I'm going to be using lines, segments, and ray interchangeably. but that does not mean they are the same. But the only difference is that there is magnitude, there is direction. So let's forget about the direction. Let's use it interchangeably for now. All right. We also have an isosceles. Okay, this is an equilateral triangle.
All right.
So from this word lateral seems like size, and this word equi means equal. So you can have equal sides or equal angle. So the lateral, the lines are equal, right? So we have the isosceles triangle. For this type of triangle, the base angles, oh no, I don't want to go to the angles yet. I want to go to the sides, you know. So for if this place is 1, this place, so this property means that this side, let's say this side is side A, B, C. So let me just name it so that you'll be able to. So for this one, segment A is equal to segment B. Segment AB is equal to segment BC, and it's also equal to segment AC. That's equilateral. But this one is isosceles, meaning that two lines, line AB or segment AB is equal to segment AC. Is that gotten? But they are both not equal to segment BC. So based on sides, and we have another one called the scaling. For the scaling now, we have something like this. This is 1, this is 2, this is 3. You see that the indication lines are different, meaning that none of these sides have equal magnitude. When I mean magnitude, I mean the size of the line. I mean, for example, 5 centimeters, 20 centimeters, 2 meters. So that's the meaning of magnitude. So this is a scaling triangle. So let's say this is our ABC. I don't know why the founders of math love ABC so much, but then you can use another, another name. So it's not equal to BC and it's not equal to AC or CA. You know, segments can go the two ways. Lines can also go the two ways. It's only a ray that cannot go the two ways. For segments, CA is the same thing as AC, and for line. But for ray, it's not the same thing because of the direction. All right. So did we get this? So we can also differentiate by angles. Now, for example, let me just say for this one now, since all sides are equal, it means all angles are equal. Please pay attention to what I'm putting. All angles are equal. Angle A is equal to angle B is equal to angle C. Now, for this other guy here, we had this angle here, this angle here is equal to the angle here, or this one is totally different. Is that gotten? Meaning that angle A, angle B is equal to angle C, but they are not equal to angle A. But for these guys here, all the angles are different, totally different. This is 1. Let's say this is 2, and this is 3, meaning that they are distinct. So that means angle A is not equal to angle B, and is not equal to angle C. Is that clear enough? Can I proceed? Please let me have your response.
Yes, ma'am.
All right. So can I clear my screen? The board?
Yes.
All right. So
Yes.
let's go to classification based on angles. For classification based on angles, our midpoint is the 90 degree, which is the what? The right angle. And don't forget, when we're treating perpendicular, we have something like this. So perpendicular angles, they meet at what? 90 degree, right? So the yardstick for this is 90 degree from our inequality. So it's either the angle we are considering is less than 90 degree, is greater than 90 degree, or is equal to 90 degree. So if I have a triangle, so okay, this triangle has a right angle. So it is called the right angle, or you might not even call it right angle, you might call it right triangle. I know it sounds somehow, yeah, but it's right triangle. But some people call it right angle, but it's right angle, right triangle. So it has a right angle that is 90. So this one does not matter. It's possible that these two are also the same, 45, 45, but that's not what we are considering. We are considering the fact that there's the presence of one right angle there. So we have an acute triangle. Okay. So for this type of triangle, let's say we have something like this. Oh, my drawing is so poor. Sorry. All right, so for this type of triangle, all the inner angle, I told you it does not matter if two are the same or something. We don't want to consider that. But in this kind of triangle, all interior angle are less than 90 degrees. I told you 90 degrees in yardstick. And for this last guy here, it's called an obtuse angle, meaning at least one of the angles. So obtuse, one angle is greater than now. So by sides, we have been able to establish the classification of triangle based on sides and based on what? Angles. So based on sides, we have the equilateral, we have the isosceles, and we have the scalene. But based on angles, we have the right angle triangle or right triangle, we have the acute triangle, and we have the obtuse triangle. Acute. This is how I know acute. This hand is your 90 degree. By the time it comes here, it's acute. And by the time you stretch it, to extend it, it becomes obtuse. All right, so let's delve right in. Okay. Let's look at the properties of triangle. This is where the main geometry is coming in. Now, the first one, we all know it. The first property is the property of sum of interior angle. And we know that. So you can say the sum of interior angles in a triangle is 2 right angle, or you say 180 degree. Right angle means 90 degree. So regardless of the type of triangle, it must always give you 180 degree when you sum it up. So you can say okay, let's look at the second property of triangle. Exterior angle property. Okay. Let's say we have something like this. Will this spirit help me to draw this right? Now, let's say you have this, and you have one angle here. Let's say you have this angle, and you have another angle here. And there's this angle that you are now looking for here. Okay, don't let me use double angle. Let me just use letters. Let's say you have angle A, you have angle B, and you have angle C. Now let's say, now if you are told to look for this angle that is here, let's say angle X, this property is saying that the exterior angle, which is this X, is equal to the sum of the two opposite angles. Okay, the exterior angle, let me put of a triangle. So what does this mean? Let's do some exercise. Then I'm going to really prove this to I'm going to prove this to you, right? Actually, we could actually prove it using long stuff, but I don't want to do the long stuff. Now, let's say that this place, for example, is 20, right? Right? And let's say this place, for example, is 60. From the property, let's call this place Y. What would our Y be from the property of triangle, which is interior angle? You know, my Y would have been 180 degree minus 20 degree plus 60 degree. Why? The sum of angle in a triangle is 180 degree. All right, so by the time I'll find my Y would have been 180 degree minus 80 degree, which would have been what? 100 degrees, right? 100 degrees. Now, if this place had been 100 degrees, right? If this place had been 100 degrees, I can decide to, don't worry, I'll still return it. Let me just clean this. I can decide to erase this. Yeah? If this place was, if this place was 100 degrees, sorry. Yeah. Okay. If this place was 100 degrees, sorry about that. You know, we can actually treat this one as a straight line. If this place is 100 degrees, definitely this S would have been 180 degrees because the sum of angle on a straight line is also 180 degrees minus 100, right? This X would have been 80 degrees, right? If we were considering this to be a straight line, I need the students to answer if they are getting it.
Yes,
Learners, are you getting this?
yes.
All right, so let me return what we had before I cancel this. So we have established that our X would have been what? 180 degrees. Let's now assume that we didn't bring in this in the first place. So let's assume that we didn't bring this in the first place. Now we have been able to clarify that this X, if it is equal to the sum of the opposite angles that are facing it from inside, that will be 80 degree, 20 degree plus 60 degree, which will be 80 degree. You will see that this theorem is correct, right?
Yes, ma'am.
All right. So let me just solve another one. Can I wipe the board? So this theorem is saying any angle outside here is equal to the sum of the angles that we have inside. Meaning that if this place was not given, okay, I'm going to do an example on that one. There is it though. Come on, let me just get fun. Sorry, had to get the fan days. Okay, so let me just wipe it for them. Continue. Okay. So let's just solve one exercise with that. Now let's say we have something like this. So we're given, and we had I can't draw this. Let me draw something simpler. So, okay, if you were told that this place is 100, and we're told that this place is 20, I like 20 too much. I'm not using 20. It's 25. So, if we are told to look for this place, which is U, and we are told to look for this place, okay, don't let us even look for that other place. It would sell it out. Now, definitely, we will just say, see the exterior angle of a triangle equals the sum of the opposite angles, right? So we say this is the exterior. So we just say 100 degrees is equal to U plus 25 degrees. So we say U is equal to 100 degrees minus 25 degrees. So U is definitely equal to 75 degrees. So that's how to get this place. Is that clear?
Yes, ma'am.
All right. So let me give you one to solve. Let's say we have I've put 20 again. I don't know what 20 did to me. All right. So let's say this so you are told to look for M here. This, who can solve M for me? Please solve M.
Yes.
So please solve M while I proceed to the next one. I want us to cover at least something very wide today. Our teachers too will answer questions. You are answering questions, Miss Martina. You are. So because you're in this class.
Okay. So
That's why
I'm also your student.
Yes, so we are all students here. You can ask me questions, so I'm a
Yes.
student.
So
So everybody
okay.
will get one or two in this national case. Right, so please, I'm waiting.
There is no problem with that.
So what's my hem? Who has gotten it?
M is equal to 80.
Thank you so much. Who is that? I said mention your name. Is that Miracle?
No.
That's who? Oh, you are not saying your name. All right, good. M is equal to 80. So M is equal to 28 degrees plus 52 degrees, and that is 80 degrees. All right, so let's go to the very last property that I'm going to be mentioning in this part before I go to the next topic. That is the number 3, other properties of triangles, inequality properties. Let me say property. So this property is very easy to prove. It says that the sum of let me even say usually. Let me say is greater than the length of the third side. This is very normal. Let's pick any triangle, but I normally like to pick right angle triangle because I usually know that one offhand. Okay. Let's say this is 4, this is 3. By the time you say 5 plus 3, definitely it will be greater than 4. If you say 4 plus 3, it will be greater than 5. If you say 4 plus 5, it will definitely be greater than 3. So this law or this property of triangles says that when you had, no matter the type of triangle, when you had 2 sides, the sum will always be greater than the magnitude of the third side, the side of the length of the third. Hello? My head, sorry, I think, I don't know if I was bounced out. I can't remember. I don't know. Okay, but let's go back to our board. Okay. Oh my God, what's happening here? Okay. Now we are going to congruence. So two for congruence, okay. Two triangles are said to be congruent they have, sorry. So two triangles are said to be congruent or are congruent if they have the same shape and size. By that, we mean, okay, for example, what determines the shape of a triangle is the angle. For example, if you have an acute angle, for example, definitely this triangle you have might come like this. And if you have an obtuse angle, but if you have two acute angles, maybe another one, the next one is also acute. If the three are acute, there's no, they will look like this. What determines the shape is the angle. For example, for right angle triangle. But what determines the size of a triangle is the length, is the sides of the triangle. By sides, I mean sides, the length or the magnitude of the triangle. Now, there are three ways to prove that a triangle, like two triangles, are congruent. Okay, these three we have three conditions that must be satisfied. Okay, in fact, let me just draw an example of congruent triangle for you. Let's say we have something like, you have another one like this. You know, I'm just drawing freestyle. If this one is 3, this one is 4, this one is 7, that means maybe, okay, let me show you a sign. So, for example, maybe it was now tilted. So that means this place is 4, this place is 3, this place is 7. That's the meaning of congruent. So it does not matter whether it is flipped over, maybe it is turned, maybe you have another third triangle that is like this. And this place is now 7. This place is, my shape is not realistic. Just forgive me. They are still congruent. Does not matter where you flip the sides. So for congruence to be satisfied, let's say, for example, you are given a question and asked whether the triangles you are given are congruent. There are three ways you can prove it. There are three ways you can prove it. The first one is this. The first one is the side to side. So that's SSS, meaning that if you compare the three sides and the three sides are equal, definitely your triangles are congruent. Once the three sides are equal, come to think of it, it's already, I don't mean that the three sides are equal like equivalent triangle. I say that the three sides of the two triangles are equal. For example, maybe you have A, B, C, and maybe for here you have maybe 2, for here you have 3, and for here you have maybe 7, and you have another one. X, Y, Z. So once AB, for example, is equal to XY, AC is equal to XZ, and BC is equal to YZ. The three sides are equal. They are congruent triangles. Another method to know that they are congruent, another way to know, that is side angle and side. For example, if you are given a structure like this, let's say the included angle, let's say you have 10 here, you have 7 here. So here you now have 80 degrees. Even if you are not given this side, you now have another one that is also saying that this place is 7, this place is 10, and this place is 80. Look at this. You will see that it follows this format: side angle, and 7, meaning that it is the angle that is separating the two sides that are given. These two things are said to be congruent too, meaning that since these three sides are equal, these three given information are equal, that means this side will definitely be equal to. They will be equal. So the third way to know, can we hear me, please? Can we hear me? So the third one is the AS. I don't know what's going on. Students, are we here, please?
Yes, ma'am.
So we have angle, sides, angle. I'm going to just end it on this congruence. So we have, for this angle, sides, angle, I've seen the format. I think
Yes.
before. I was bounced out. Okay, that means you are given an angle here. You are given a side here, for example. Don't let me keep using here. Let's say you are given an angle here, you are given an angle here. Then the side is in the middle. Let's say you are given 8 centimeters. Here you have 50 degrees, and here you have 60 degrees. If you have another one that was given, and for here you had your 50, you had your 60 here, and you had your 8 centimeter here. They are still congruent. Why? Because there was an angle given, there is this 8 centimeter and there is this 60. Meaning that if this place say that, oh, the angle, if this place is now saying that, oh, this one is 9 centimeter, definitely this place will be 9 centimeter. If this place is 2 centimeter, definitely this place will be 2 centimeter. That's that on congruence. I think I have one more to go. That is RHS. Are we done with what is on the screen? Let me clean this part. I think I've written this one for long. Don't mind me, oh, it's a lot of work trying to put down slides on this thing because I have to still draw. All right, we have the RHS, and this one applies to the to the right angle. So this is right angle. Hypotenuse, tenuse, and another side. For example, that one is even easy to derive. If your right angle is present and they told you this place is 5 centimeters, they now told you this place is 2 centimeters. Definitely, if you have another one, okay, I want to draw it to face another side. I said if this 2 centimeters. If you have another one that is facing like this, this is 5 centimeters, and they told you this is 2 centimeters, meaning that if they are congruent, since your right angle is there, the hypotenuse is the same, and the angle, the other side you are given are the same. Definitely, if this place is y, this place will also be y. Let me look for a question to solve on that. We are talking about congruence. How to know that two triangles are exactly the same. For example, you are given two triangles. One information is on one side of the triangle, another information is on another side of the triangle. They are not saying solve for y when you are not giving information on a particular angle. Once you know your congruence law, you can easily solve for it. I'm looking for I had one example on that. So look at this. This one say we have a triangle ABC. And they said we have another triangle DEF. They said our AB is equal to. They said our AB is equal to our DE, and they are both equal to 5 centimeters. They said our AC is equal to our DF, and they are both equal to 6 centimeters. They said all our angles, they said our angle A is equal to our angle. Okay, let's put this in. They said this is 5 centimeters. They said this is 5 centimeters. They said this is 6 centimeters. They said this is 6 centimeters. They now say angle A is equal to angle D. So they are asking us, are these two triangles congruent? They said these two angles are equal, meaning that if this one is 20,
yes,
this one is also 20. Are they congruent? Are they congruent? Are they congruent?
yes.
All right. Which of the properties do you use? Is it SSS?
Yes,
Is it SAS? Which of the properties did you use?
Side on one side.
Yeah, good.
SAS.
SAS. Correct. Correct. That's beautiful. Help yourselves. You tried. That's amazing. I didn't know you can get that at a go. So by SAS, it is congruent. Okay. Let's say we have another triangle. We have triangle MPO. And we are told that this place is 60 degrees. This place is 20 degrees. Then our OP is 5 centimeters. We have another triangle. X, Y, Z. We are told that this place for this one is 60 degrees. This place is 20 degrees. And this place is 5 centimeters. Are they congruent? Are they congruent? By which property?
Yes.
By which property? This is what?
ASA.
ASA. Good. Let me see if you actually really understand. Okay, let's say we have another one. You see what I drew now?
This one.
Are these two triangle EFG and triangle MNO? Are they congruent? Are they congruent?
We can see.
Are they congruent?
Yes.
Why? Check it again.
I cannot see it.
Oh, let me then clean the board and redraw.
It's not clear.
Okay. Don't worry, you see this one. So 5 centimeter and you now have another one. Are they congruent?
No.
Why? Yes.
How she's doing is congruent.
They are congruent.
Are you sure?
Because angle MH is equal to angle MH is equal to angle JK. Then MH. No, they are not congruent.
Thank you. They are not. Because looking at the position, they said side angle side, right? This one is not even in between. It's not even in between two angles. This one is in between two angles. So they cannot be congruent because of the positioning. You get the whole idea of congruence now. So these two angles are not congruent. Now, let me give you the symbol for congruence. Is that gotten? This symbol, oh, sorry. Oh. This symbol means congruent to. So that means triangle MNO is not congruent to triangle. You know, when we put a slash over something, it means it's not equal to or it's not, right? It's not congruent to triangle KKL. So let me give you one more to solve before I go. I would have wished to go to equality, similar angles, but time has gone, except our moderators do. We started very, very late. Moderators. Ms. Martina.
Hello, ma. Sorry, I'm with you.
I said I would have loved to go one more on equality, but we really started late.
Okay.
But I don't know if I can just quickly mention
actually class, so
okay, let me just mention.
Sure, you can.
Okay. All right, so let's go to similar.
So we can still get to continue.
No, I want to end it here so that we can go to the next topic. Okay, I don't want to bore them too much.
All right, no problem. Over to
That's
you.
why in normal school we have geometry 1.
Sure.
You go to another topic before you go back to geometry 2. It helps retention. When you do something for a very long time, you get bored. So as an educator, I don't want to bore them.
Yeah, that's
so let's go to another topic then. Maybe if God permits, in another session, I can have the opportunity to be invited. All right, so let me just treat similar triangles with you. I hope you are enjoying your class though. You're not even answering.
Yes, I'm also enjoying the class. I enjoy the kids.
Okay. I'll just write the definition. I'm copying it from my board and from my notes so that I will not waste time. I told you angles are responsible for shapes, while size is a factor of your magnitude. So what this is trying to say is that if I have a triangle now, let's say this place is 30, this place is no, I don't want to make that place 40. This place is 25. This place will be what? This 55 already. So we are left with 1, 2. So this place can be 10 centimeters. This place 5, and this place 7. What this one is trying to tell us is that they might have different shapes. They might have different sizes, sorry. So this place can be, oh, I don't like the outcome of that line I just drew. Still the same thing. Oh, God, I beg. Okay, so if this place is 20 centimeters, this place is also 125. This place is 30, and this place is 25. This one will be 14, sorry. And this place will be 10 centimeters. What this is trying to tell us is that we can have similar angles, triangles, where the proportion, they are proportional. Maybe this one is 1:2, for example. You see that this angle we have here is like the smaller version of what we have here. This one is magnified version of this. So similar angles, similar triangles have the same angles and they have the same proportion. By proportion, I mean 9. For example, let's say, but provided that the angles are the same, we can also represent this by this same line. So once the angles are the same, that means they are proportional to each other. They are similar. For example, now let me ask a question on this. Let me do an example. So, given that all angles in triangle ABC are equal in size to triangle EFG. AB is equal to 2 centimeters. BC is equal to 10 centimeters. And EF is equal to 1 centimeter. And FG is equal to 4 centimeters. Now they are not telling us find side AC. Now, let me clean this up apart. I want to interpret this up here. So they told us that all angles are equal. They don't have to tell us all the angles. So since they already told us that all the angles are equal, so this is A, B, So they told us that our AB is 2 centimeter and our BC is 10 centimeter. They told us that our EF is smaller, so I want to draw it to be realistic. Since they told us that our EF is 1 centimeter, they now told us that our FG is cos EFG. They told us that our FG is 4 centimeter. Now, and they gave us something like this. Look at that. Oh. I want you to check the screen, please. So they gave us something like this. They told us, now, meaning that this one is congruent to this. So what ratio? Let's do the ratio aspect. So this one is AB is similar, Abi, is similar to EF, Abi, is similar, is proportional. Let me put that. Our BC, by the virtue of the shape that we have, the sign that we have there, is proportional to the one that has to EG, right? Therefore, our FG is proportional to our AC. We can say AC is proportional to our FG. Now, since this one is known, this one is known, these two sides are known. So we can say 1/2. We told you that our ratio must always be the same. Is equal to, which one are we looking for? Why AC is proportional to which side? To FG is equal to y/4. Now cross multiply. That means your 2y is equal to 4. That means the y that you are looking for is 4/2, which equals to 2. I don't know if you get that. 2 centimeter. Let me come again. Let me come again. You know, I said proportional or similar. They said this one is similar to this, meaning if this one is 2:1, right? This one is proportional to this. That means this one is 10 ratio, let's say this place is Z now, Z, right? And then I say this place is also proportional to what? To this place. That means this one is Y/4. Now, we have no business with this one. What they said we should look for is our Y. So we'll use one known side together with this. 2:1 is the same thing as 2/1. 2/1 is equal to Y/4. You see, I've used another method, but it's still the same thing. So Y, no, what are we doing? Am I doing the right thing? Oh, I guess I made mistake the first time there. 2 is similar to this, okay? This one, this 10 is similar to Z, okay? And this one here, I think I made mistake the first time. So is equal to 8. Now, let me repeat the method I did the other time. Let me see where my mistake came from. This is 1/2, right? 1/2 is equal to 4/y. Okay, that was where I made mistake. So cross multiply, it should give you the same thing. That's what I'm doing it again. Y is equal to 8. So the Y we are looking for now is equal to 8 centimeter. Do you get that? Are we still here? Hello?
Hello.
Do we get that?
Yes, yes.
So let me just give you one question before I call it a day. No, I'm not using 6. I'm using, let's say, 18. This is 21. Now, look for X. So let me, without giving you this, you already know how to find congruence. So you already know that this place is congruent to this, or is similar. So there are sometimes they will not even give you. Now look for X in that one. And for the second one, I already gave you the property of this one. I want to see if you would get this. Now you are told to look for your V. Now let's solve those two. I call it again. Who has gotten the first one? It's straight up. You can just look at it and decide what the answer is. Just look at the proportion. What's my X? We call this ABC, B, E, F. You're welcome.
Yeah, I think they're just draining back again. So you just give them some minutes to do the calculation.
Hope people got my explanation. This part is 18 centimeters. I know mistake that. Who has gotten the first one? Are we done?
But they have a network issue. We have not solved anything yet.
Oh, did you get my explanation before the network tripped
No.
off? Oh, geez.
No.
Let me go back to the example I solved. But you understand similar triangles.
Yes.
So for this one, I said we were given two triangles and we're told that the three sides were equal. The three sides were equal. And they now say if this triangle is A, B, C, I hope I can be able to record the example I used. And they said this place is 10 centimeter. They said this place is 2 centimeter. So we have D, E, F. And I told you this line helps us to know which ones are equal or which ones are similar. So they now told us that this place is similar to this place. They told us that this place is 4 centimeter. And they told us that I can't remember what I used. Okay. Okay, they told us that this place is 1, right? And they told us that this place. Now let's compare the ones that are similar. From A, we'll be doing A ratio. I told you that they are proportional, right? Meaning that it can be magnified or diminished. It can be 7:9. Let's look at these two sides that are equal. This is 2:1, have you? I'm comparing these two sides that has 1:1. So I said this place, the ones that have 2 is this one and this one. Okay, no, I said this place was, I'm coming. This place had 3. Sorry, I'm forgetting. Okay, I said this place and this place are also proportional, right? I said, they said we should look for this X. So I said, assuming this place is maybe Y, this will be, this one with 2 lines and this one with 2 lines will be 10 ratio what? Y. And this third one that are similar would have been what? X ratio 4, right? But from the question, they said we should look for X. I just had to name this place Y.
Yes.
Because I needed to. So let's just use these two that we know. These two that we have business with. This one is unknown, so it will give us complex equation. But this one, since we already know it, and I said ratio also means division. So 2/1 is equal to, since they are similar angles, meaning their proportion will be equal, is equal to X/4. So we'll now cross multiply. Therefore, our X will now be what? 8 centimeter. Meaning that this S here is what? 8 centimeter. If you don't want to do it that way, you can say this side that is known and this side that is known. What did you do to them? Okay, if you divide this one by 2, you will get 1, right? If you divide this one by 2, but I don't want to use the division part since it's this that I'm looking for. So you can say this one times 2 is giving you your 2 here, right? And you can say, since this place is given and you are looking for this place and they are both 3. So all you need to do is to also multiply by the same number, just like your equivalent fractions, right? This will be times 2. So since any side of this place is times 2 of the corresponding angle here, the corresponding side here. Do you get that? Did you understand?
Yes, ma'am.
Okay. So now
Yes, ma'am.
We are now giving this exercise. We know that this place is 7, this place is 6. This angle in the middle is 30. And they already told us that this place is similar to this place. Now, since we are given that this place is 15, what is this side going to be? So this place is 7, is corresponding to this. What did you do to 7 to get 21? Look at this one. So this one is 6, this one is 18. What did you do to 6 to get 18? So definitely you must do that same thing to this thing to get 15. Do you understand? So what's our X?
Please, I'm coming.
And just helping you to write it out here so that you understand. So this is also proportional to 15. So look at what has happened from year to year. What did you notice?
Ma, from where?
I'm saying that this line, this one line and one line means that this and these ones, they are similar. So they have one line, right? So look at whatever has happened to 7 that you can
Yes,
that
ma'am.
can happen to 7, either multiplication or division, that will make it give you 21. If that part. They said this one that has 2 lines here, this one has 2 lines. They said it's proportional to this, to 2 lines.
Yes.
So this 6 has become 18. Definitely, which number will become 15? This is 3 lines. This is 3 lines. Do you get it now?
Yes.
What will our x be?
Our x will be 6.
I don't think you understand.
This thing is not clear and net is not able.
Okay.
Yes.
Please, let's listen up for the last time. I said this one line is ratio. I told you this thing,
Yes, ma'am.
in between, they are similar. So it's ratio that is separating them. So whatever you pick ratio, whatever you pick here. So since this one is one line and this one is also one line, they are similar. You get that? So this is 7 ratio what? 21.
Yes.
Right? This one is 2 line.
21.
Which one is also 2 line on this side?
18 centimeters.
So that's 6 ratio what? 18, right?
18.
This one has 3.
Yes.
Which one also has 3? On this side, which one has 3?
15 centimeters.
15. So this is S ratio 15. I said there are 2 ways you can look at it. You will say from 7 to 21. Is it multiplication that will make you get 21 or division?
Division.
Okay, division now. But don't worry, let me help you out. So I said that just pick any of these 2. And you can pick this one and this one. I said ratio is the same thing as division. So this is 6 over 18 is equal to 8 over 15. Then you do what? Cross multiply. 18x is equal to 15 times 6. So your x is equal to 15 times 6 is 9. Is that 90? Is that 90? 90 over, is 90. 90 over 15 over
Yes.
15 with
Yes.
5. That's what I expected you to get. So if you look at this, 7 times 3 is giving you 21, right? 6 times 3 is giving you 18. 5 times 3 is giving you 15. That's the idea. Whatever you do to one side here to get this side is what you do to every other side. For example, 21 divided by 7. 21 divided by 3 is giving you 7. 18 divided by 3 is giving you 6, and 15 divided by 5 by 3 is giving you what? 5. You've understood that now, right? Do you understand?
Yes.
Okay, can you solve this second one? Let me just give you an expo. This is an
Yes,
isosceles.
ma'am.
This is an isosceles triangle, meaning that whatever you get here is whatever you get here. That's why I did not give you. Do you get? These two is equal to these two, and they are both similar to this thing here, right? So tell me what I'll write on the board. Because of the time, I have something to do. Someone has been waiting for me. All right. So you said you understand the first one, right? Now let's interpret this question. They said we should look for our V.
Yes.
Let's assume that this is our V. Our V will be ratio what? V has 2. Which other one has 2 here?
Ten centimeter.
Okay, so that means V ratio what? 10 centimeter. 6 has 1. Which one has 1 here?
10 centimeter.
No, this one.
12 centimeter.
So that's 6 ratio 12. You will just
That's
say that.
12 centimeter.
That will now be what? You change the ratio to what?
To division.
Yeah, good. Is equal to 6 over 12. From here, just cross and multiply. 12V is equal to 60. V is equal to what? 5 centimeter. Did you get that? You can as well
Yes.
say from 6 to 12. How do you get 12 from? How do you get 6 from 12? You can say 12 divided by 2 is 6. You can say 10 divided by 2 is also going to give you an answer. Do you get that now?
Yes, ma'am.
All right, so see you next time. I don't know when that will be. So I'm done, Miss
Thank you very much.
Martina. Bye. Thank you for the class. Yeah, bye.
Thank,
Bye-bye,
thank
ma'am.
you so much.
Hope to have
So,
you again.
Oh, yeah,
we
I
hope
love
for
to
the
have you
next
too for that.
class. Yeah,
Yeah.
next week. All right, ma. Take care. Enjoy the rest of the
Thank you
week, ma.
for the
Bye.
opportunity. Bye.
Bye, girls. see, see you same time next week. Yeah.